It was incredible. I mean, you have robots from 4 different manufacturers, which I don't know if anyone's worked with industrial robots that's listening to this, but like to get those things to cooperate with each other is no easy task. I mean, everything's got its own proprietary language. I mean, by design, like the business models of a lot of these companies is like, I only want to work with stuff from my same brand. So whether it's like, Fanuc, Yaskawa, ABB, Universal Robot, whoever it is, it's just traditionally very locked down. Maybe you are less so. And then the other ones I think are opening up more with like Ross drivers and stuff like that, it seems. But
yeah.
What you guys did that was so incredible was there's this demo, and basically I think you called it the Twister demo, right? So you have buttons and robots, and the user, in this case me, got to pick different positions that I wanted the robots to hit on this grid, and then without crashing into each other, which is way harder than it sounds for somebody that has never programmed an industrial robot or been around one. These things went over each other and around each other, and were able to hit all these buttons and do it in lightning speed. Like it's super cool.
Yeah, it's a great demo. We did nickname it Twister. We actually brought it all the way up to Automate in May there in Detroit.
I saw it there too.
Yeah. We have a great guy in the office who designed, built, and programmed that. And by the nature of our software, the whole point, the existence of our company is to make industrial robot programming easier, faster, and by default more economical. And what we were doing was we always had visitors, could be potential partners or investors or customers, and we didn't have a cool demo, and we bring them into the conference room and bore them to death with 50 PowerPoint slides, trying to tell them what we did.
Been there.
Yeah. And
unfortunately.
And it was quite a waste of time and not that interesting for most involved. And we made a decision. We got to build a demo that tells the story, or tells a big portion of the story of what we do. And there's 2 demos there, which tell 2 important stories of what we do. And so most of the time now, when you come into the building, the demos are in the entrance, as you remember.
Yeah.
And so you don't make it to the conference room because it's much more fun to hang out with the robots and press buttons. But you're right. It tells the story, if I may.
Of course.
That the software is robot agnostic. And what it does is it auto-generates collision-free motion plans for industrial robots and cobots. And we needed to find a way to kind of show off all of the main value propositions. Okay, so one of them is, as you said, there's 4 different robot brands all on this table, plinths, working really closely together. So a lot of opportunity to crash into each other, right? And so that you don't often see robots so close because it's so difficult to program manually. And okay, so it's robot agnostic. And then they're very close. So how do you program them that they don't collide? And how can we prove to visitors that programming them now is easy and it's auto-generated and people don't have to waste hours and days and weeks and quarters programming industrial robots when they could actually be working on something more valuable, like the process that they're involved in. So we allow visitors to use the interface in the touch screen, and there's light targets there. It's like the equivalent of spot welding, but in a fun kind of Twister demo kind of format. And when you do the math, actually, there's 4 robots, and I think there's 17 targets. So the number of possible permutations to send robots to each target is north of, I don't know, 1.7 million or something like that. So it's very interactive, and you can come in and just allocate the targets per robot and then hit go. And there's no delay. Those robots will fly.
It just figures it out.
Full speed to the targets without colliding with fixtures and without colliding with themselves. And then we added a new cool feature on top of it, which was Resolver, which is what we just launched at Automate, which is this hyper efficient optimization software. So when you come and you allocate the targets per robots, you'll get a certain cycle time, let's say 17 seconds. And then we'll say, okay, well done, human. Now will that Resolver do it? And Resolver will come up with the most efficient target sequences and target allocations and motions for those robots to take, and it typically cracks it in somewhere between 5 and 6 seconds.